Hey everybody, and welcome to How-To Videos with Dr. Amy Gates. This video is going to focus on how to calculate measures of central tendency like mean, median, and mode, and also measures of variation or variability like standard deviation, variance, and range, all using StatCrunch. So here's the data set that we're going to work with, and let's talk about the variables and their types first before we get started. This is a student data set, so it gives a student ID, the age of the student, the year in school, like freshman and sophomore and junior and senior, the gender of the student, their GPA, the score they got on the final exam, and the number of classes they've already completed towards their degree. So the variable ID is qualitative, it's nominal, and it's discrete. In other words, this is a quality, it's not a quantity, this is not a real numerical value, it's more like a name for this student because we don't want to use the student's real name. And these numbers are not numerical, so this student is not greater than that student, for example. These are just categories or names. That's why they are nominal. They have no order associated with them, and they describe a quality, which is why they are qualitative. The age of the student is actually quantitative. It is a real quantity. The student is in fact older than that student and is older than that student and so on. Age is a continuous variable because we continue to age at every moment of every day. So even though you don't see any decimal places here because we've rounded up to the nearest year, age is still a quantitative and continuous variable, and that's important. The year that a student is in school is qualitative, it's a quality, but it's also ordinal data rather than nominal. It's ordinal because there is an order. Freshmen are first. They start first, I should say, and then we have sophomores, then we have juniors, then we have seniors. So in fact, seniors have been in college longer than juniors. So even though this data is qualitative, we can't subtract a, let's say, junior from a senior and get a freshman. That doesn't make any sense. We can't do that. So they're not real numbers, but they are categories that are ordinal. There is an order associated with them. So qualitative, discrete, and ordinal data. The gender is a variable that is nominal and qualitative. Definitely just a quality, no order associated, male and female. And instead of using numbers, I went ahead and used a string or a name to represent male and female. The GPA is our next variable that is quantitative and continuous. GPA is always rounded up to the closest two decimal places. But in reality, if you calculate a person's GPA, it can have many decimal places, it's just rounded up. So GPA is quantitative, it's a real quantity, and it is a continuous value. Final exam score. In this case, we've rounded up to the whole number as well, and depending on how the final exam is graded and so on and so forth, we would have to maybe define whether it was a discrete or continuous value. It's continuous if a student can get any value at all between, say, 65 and 67 and 70, that any value is possible. That may not be the case. In this case, it may only be possible to get a whole value on the final exam. So let's say that it is, and a decimal value is not possible on the final exam. That makes this discrete, but also quantitative. So this is a real number. This person got a 65, this person got a 67, this person did better than that person. The difference between their exams is 2 points, so all real numbers, so quantitative. However, we're going to say it's discrete because there's no possibility of getting a decimal value on this particular final exam. And the number of classes completed is also quantitative. It's a real number, but it's also discrete. Person cannot complete 0.85342 classes. They can only complete 11 classes or 8 classes or 4 classes, always a whole value. So again, quantitative and discrete. So what we're going to do here now is we're going to use StatCrunch to calculate measures of central tendency. So measures of central tendency is a fancy expression for where's the center or middle of your data. And there are 3 different ways that we can find the middle of a data set. We can take the mean, which is also known as the average. We can take the median, which is the actual center of the data. If we put our data in order and pick the middle spot, that's the median. And we can choose the mode, which is the most frequently occurring value. The mode often makes sense when your data is qualitative and maybe either nominal or ordinal. Mode does not make a lot of sense when your data is continuous and quantitative. For example, the mode for GPA would be non-useful. It would not be a good measure for us. Whereas the mode for year in school will tell us which year in school we have most of. Do we have more sophomores? Do we have more juniors? Do we have more seniors? So it does depend on the type of data and the information that you're trying to get from that data as to which measure of central tendency, which is also called a numerical measure, that you're going to utilize. And you can use more than one as well. We're also going to look at measures of variation, like the variance of the data set, the standard deviation, which is the square root of the variance, and the range, which is also a measure of variability. The variance of a data set is the average of how far each data value is from the mean. So if all your data points are really close together, your variance is going to be smaller. If your data values are spread apart really far, your variance will be larger. So let's see how this works in StatCrunch. If I click on Stat and then Summary Stats, I then want to choose columns because my data is arranged in column form. All of my ages are in one column, all of my genders are in one column, and so on. When I click on column, StatCrunch wants to know, okay, which variables would you like to make calculations for? Now I'm going to take the high road and I'm going to choose all of them at once so I don't have to go back and calculate mean and median and mode and variance for each one individually. I'm just going to do them all at once. Now if I click ID and I get excited, I'm like, okay, now I'm going to click age and now I'm going to click year. But what's happening is every time I click one, it replaces the one that was there. That's not what I want. I want them all here. And in order to do that, I need to find the control button on my keyboard and I need to hold down the control key to choose more than one variable. If you're working with a Macintosh computer, you need to use the command button. So now I'm going to go back to ID, but now I'm going to down the control key on my keyboard. You can't see this, but I'm doing it. Now I can select more than one variable. So again, it's command on a Mac and control on a PC. Now I've got them all selected and you can see them all here on the right-hand side. My next step is I would like to calculate certain statistics, certain measures for all of these variables. I'm going to clear this out just by clicking over here. N is the size of my data set. I'm going to go ahead and leave that there because that's always good information. And using the control button again and holding it down, I want to calculate the mean for all my variables. I want the variance. I want the standard deviation. I'm going to continue to scroll down. I'll go ahead and calculate the median. I'll calculate the range. I'll take the min, the max if I wish. And I'd say that's good for now. There are other videos, by the way, on quartiles and interquartile range if you want to check those out. So what do I have here? I'm going to calculate the sample size, the mean, the variance, the standard deviation, the median, and the min and the max. Okay, great. In order to do this, at this point, I just click Compute. Once I click Compute, StatCrunch, for all the variables that I've chosen, calculated all of the numerical measures that I selected. So let's start with age. For the age, I have 20 values in my data set, which is true. The average or the mean age is about 38.9. Okay. The variance is about 249. Normally the variance, the number itself, doesn't make a lot of sense because it's a squared value. But the standard deviation is the square root of the variance. And the standard deviation gives you an idea of the spread of your data. For example, the mean age is 38.9, and one standard deviation is about 15.79. So using the empirical rule, plus and minus one standard deviation from the mean gives me about 68% of my data. And we'll have a different video on that, but the standard deviation can tell you or give you an idea of the percentage of your data in each area. Next, we have the median, which is the center of our data. Notice that the median is a little smaller than the mean, and so that means that some of our values are pulling the mean up. The mean is affected by outliers or large data values. So if you have very skewed data or some very strange data values that are either really huge or really small compared to the rest of your values, the median might give you a slightly better or more accurate measurement of your data, because the median is not affected by outliers or large or small data values, because it is exactly the center of your data. Here's our range, the largest number minus the smallest number. Here's our min, so the youngest person's 21, and here's our max. The oldest person is 78. The max minus the min is where we get our range from. So you can see that using StatCrunch is a very straightforward way to get the mean, variance, standard deviation, median, range, min, and max of any of the variables in your data set. Thank you for joining me.